Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 2. We are talking about derivatives. So for the previous few lectures, we talk about the derivative rules like product rule, quotient rule, and also we talk about the different derivative formulas like what is the derivative for the polynomial, for the exponential. And in this lecture, we're going to talk about a special, a set of the special derivatives formula is for the trig functions here. Okay, so now let's go ahead and go to our lecture notes. And let's go ahead to get started here. Okay, so, before we are talking about the formula for the trig function. So in here, the first things here, I want to talk about a couple limits involved with the trig function. And in here, I'm not going to prove it. And I'm going to prove it in the later units. And in here, I just want you guys to take this, okay, this is kind of like a part of field formula. The reason why we want to have this limit for the trig function is because later I'm going to show you, how do I derive the trig function formula by just using our limited definitions here. Okay, so the first thing is here, the first limit formula, it will be the limit. Okay, so when the x approach to 0, and this is the sine x and over cosine x. As you can see, if you plug the 0 to here, you will be the sine 0 over 0. Sine 0 is 0, so it's 0 over 0. But we know the 0 over 0 in general is not equal to 1. But in here, we say, okay, this is equal to 1 here. And like I said, I'm not going to prove it in here, and we're going to wait for several lectures later, then we'll be able to prove this easily. Okay, in order to use this formula, be careful here. This x and this x has to match here. Okay, so if you have a sine 2x, then the bottom here, you have to have the sine 2x here. So they have to match. We're going to do some problems. You will see how do I manipulate to match those things. Then the another limit is important limit we need to know is we said limit x approach to 0, and then this is the x and this is cosine x minus 1 here. Like those two limits are the limits we're going to use to derive the formula. So for these limits here, as you can see, when the x approaches to 0, so this will be 0, then cosine 0 is 1. So this is 0 over 0 again, but this one is equal to 0. Okay, so that's why I need to very, kind of important to remember those two limits. Like I said, right now, let's just take it for granted and not going to prove it. But later, in the later lecture, in the later units, we'll be able to prove it very easily. Okay, so now let's try, and also in here, the same things here, the x here, they have to match here. Okay, so now let's take a look here. The first one, so this one's here, this is the limit x approach to 0, 1 minus cosine x over x. So I can rewrite this one. So limit x approach to 0, right? So this is x. If you reverse these two, so you take the negative sign out, so you will get a cosine x minus 1, right? Then by the formulas here, right? So here, by the formula limit cosine x over x, what is that? Is zeros, right? So then that will be what? So this thing here is 0, so the whole thing is 0, right? So because this one's here based on my formulas here will be 0. Okay, so now let's take a look. The second one's here. The second one here, this is limit x approach to 0 and the cotangent x. So we know the cotangent 0 is infinity. So 0 times infinity, I don't know what is that. Okay, so now let's see how do we solve this one here. This is limit x approach to zeros, right? So here this is x. What is cotangent? Cotangent is cosine x and sine x, right? Okay, so now this one's here, you will have a limit x approach to 0, and then here this is x cosine x over sine x. And then you flip it. So this will be limit x approach to 0, and then when you flip it, then the sine x going to the top, and then the bottom stays x cosine x, right? Okay, now I'm using the limits law. Take a look. This is sine x over x. So this here, right? So sine x over x. So when limit approach to 0, what is that? Is 1, right? So this approach to 1. So this would be 1 times. And then when the x, when the cosine x here, when the x approach to 0, what is this one going to be? This one are going to approach to 1. So that's why the answer will be 1 approach to 1, right? Because the cosine x is 1. So what is the answer? Will be 1 here. Okay, so now let's take a look at the next ones here. So remember, right? So this one's here, I said, okay, I want to find the limit x approach to 0. So here, this is x approach to 0. Remember, you have to match sine x over x. So I have x squared. So what I can do, I can take one x out. All right, so then here, this is sine x. I have another x left here. Correct, x times x is squared. So now I have a 2 here. And now take a look. What is this one here? This is x over sine x. So I know sine x over x is 1. So then the x over sine x is also approach to 1. Am I right? Yeah. So now in here, the x approach to 0. So this one approach to 0. So 0 over 2 is what? Still is 0. So what is the final answer for this ones here? Is zeros here. Okay. All right. So now, like I said, I'm going to use these two limits since to help me to prove. So first, let me write it down, the sixth, the derivative function for the trig function. Now I'm going to prove one of them. And so let's just see. Okay, so what is this 6 here? So let's say that here dx, the sine x. Okay, so the sine x is equal to what? The derivative is equal to cosine x. Okay, so then the next one here is the dx, the cosine x. So what is the cosine x will be? Is negative sine x. Then the next one here is the dx, the tangent x. Okay, so what is the tangent x? Will be the derivative is secant square x. Okay, so now we just do the reciprocal. So this is dx cosecant x. So what is the cosecant x here? The cosecant will just be negative cosecant x cotangent x. Okay, so the same way is here. This is dx, the secant x. So the secant x, the derivative will just be the secant x tangent x. Okay, then the reciprocal of the tangent is cotangent x, right? So the cotangent x is just equal to the negative cosecant square x here. Okay, so those are the 6 formulas. So you will wonder, how do I get those, right? So I'm going to show you how do we get it. So the one I'm going to prove is this one. Okay, so other you can do the same way. So why the derivative of the sine x is equal to cosine? Okay, so recall, let's refresh our memory what we did. We said f prime x. We said the derivative. How do we define the general derivative? We say is limit h approach to 0. Then what here is h f of x plus h minus f of x. Correct? So this is the formula we use. Okay, so now let's try to find the sine x derivative, right? So I said the derivative of the sine will be equal to the limit h approach to 0. Then here is h. Then you have a sine x plus h minus sine x. That's right. That's how I use the definition about the, you know, the derivative. Okay, now in here, this is limit h approach to 0. Then h is here. So what is the sine? I'm using the sum formulas, right? So if let's see here, so recall the sum, like the sine a plus b. That's what we learned in the pre-calc. What is this one? It's sine a cosine b plus cosine a sine b here. All right. Okay, sounds good. Okay, so now let's try to break this one. So this will be sine x, correct, cosine h plus cosine x sine h. All right, and then minus sine x. All right. Okay, so now take a look, right? So h approach to 0. All right, so what I'm going to do is here, I'm going to combine this term and this term together. I'm going to break these big fractions, right? So I'm going to say here, this is h. So the yellow term is sine x. Can I factor the sine x out? Yes, I can factor the sine x out. So the yellow term, right? So what is here? This is cosine h minus 1. Correct? Okay. Now I have the middle term. So the middle term is this green term here, right? So I have this green term left. So this is h. I just have what? Cosine x sine h. And by the law of limit, if you have the limit for the sum of the two functions, you can just separate that. So this is the h. This is the sine x cosine h minus 1 plus limit h approach to 0. So this is h cosine x sine h. Okay, now see how pretty that is. So here, look here, this part cosine h minus 1 over h, back to my formula, back to here, right? Cosine x minus 1 over x when x approach to 0. So in here, this is a cosine h minus 1. So what is this thing's approach to? This is approach to what? Approach to zeros, right? So if this approach to 0, then the 0 times sine, so the first term will approach to 0. Now you take a look here. The second one here, this is sine h. So based on my formulas, I know sine h to h, what is this thing going to approach to? Approach to 1. So here, that's why you will have here. So what is this term left? It's plus 1 times cosine, right? 1 times sine, 1 plus 0 plus cosine x. So this is cosine x. So that, how do I prove, the derivative of the sine x is cosine x. And you can do the same things, to prove the other 6. That's why we introduced these 2 limits conditions. Like I said, these 2 limits, why it is, and right now I'm not going to prove it, and we're going to talk about that in the later, right? So you kind of take these 2 for granted for now. We're going to prove in a later lecture. Okay, so now our life is easy. Okay, so now let's see what is here. So I want to find the derivative of y prime here. All right, so here the y prime will be, okay, sine, what is sine? Is cosine x. So what is the cosine x? So this minus is still here. What is the cosine x? It's a minus sine, right? Hi, the minus sine x. So what is the final result? It's cosine x plus sine x. Yay. Okay, so now this is the tangent x to the x plus 1. So what is the first things we need to do? Oh, you see a fraction. So what do we need to do? The quotient rule. So you square the bottom. Then what you do here, you take the derivative of the top, right? So the tangent, what is the derivative of tangent is secant square x. Then you keep the bottom, now moving. Then move minus tangent x. Then times the derivative of the bottom. What is derivative of the bottom? It will be what? It will be 1, right? So your answer is here. If you want to combine it, you can do that. So it's x plus 1 square. So this is x secant square x plus secant square x minus tangent x, right? So that will be the answer. Okay, now in here, so what is y prime? Oh, I see here sine pi over 4. There's no x. So what is this? This is what? This is a constant. So I know anything, if a constant, so what is my derivative? Is 0, right? Okay, now let's take a look at the part D here. So part D, you see y prime here. The y is x cubed plus sine x. This is x cubed, and this is a sine x. Oh, it's a product. So what rule I'm using? I'm using the product rule. So take the derivative of the green one. So it's 3x squared. Hold the yellow one, sine x. Then plus, hold the green one is x cubed. What is sine x? Is cosine x, right? So if you like, you can combine it. You can take the x squared out. So this is 2 sine x plus x cosine x. All right. Okay, so now let's take a look at part E. So this one's here, this is y prime. So the first term is easy. The second term is here is the same thing. You have a 2x here, and you have a cosine x here. So you will need to use the product rules, right? So you need to use the product rule. Okay, first term doesn't use the product rule. X squared, what is the x squared? Is 2x. Then the product rule, you take the derivative for the first one. So 2x will become 2. Then you have a cosine x. Then hold the first one, 2x. So what is the cosine x derivative? Is negative sine x. All right, so here I have a 2, 2, 2. I can factor 2 out. So this will be the x, right? So plus cosine x minus x what? Sine x. Okay, so it's pretty straightforward to apply the formula. Okay, so now the next thing is here. We say is x cosine secant x plus 1. Well, immediately I know what rules are quotient rules, right? Okay, so let's try the quotient rules. What is the quotient rule? Square the bottom. So secant x squared plus 1. Now take the derivative of the first one, the top one. So x is 1. So it's 1 times the secant x plus 1. Then minus x. Then the secant x plus 1, you take the derivative. What is the secant x? Will be the secant x tangent x, right? Then plus 1 will just be 0. Right. So now if you want to, you can combine a little bit. So you will say this is secant x plus 1 to the square. So secant x and this secant x, you can factor that out, the secant x. So it's 1 minus x. And you have 1 secant x, right? So then it's plus the secant x, or plus 1, I'm sorry. Okay, then you can have this 1 here, right? So you will have 1 hold on, this one is not right. I did not. Okay, so okay, then it's minus. So here, all right. So here, this one here. I need to be careful here. So you put the second x out. So this is will be 1 minus x tangent x, right? Then you have 1s here. All right, that's it. Okay, so now the next thing is here. Let's take a look at problem number 3 here. Okay, so the problem number 3 is that where the graph has horizontal tangents. Okay, all right, horizontal, and the keyword here is a tangent. So I know the slope is what? The tangent line, slope of the tangent line, it is the derivative. So the first thing I want to take it is derivative. So I say f prime x. All right, so this is square root of the sine x. So sine is what? It's a cosine. So it's square root of cosine x. Then plus 3, so it's minus 3 sine x. Right, because the cosine x, the derivative is minus sine. Okay, so what means horizontal? That's very important, right? So horizontal, that means the slope of the tangent line. Because it's a horizontal, so what is the slope here? Will be zeros, right? So that means that I need to set this equal to 0 and I try to solve for x here. Okay, so now, okay, if you set this one equal to x, then you will 0. So you will have a square root of the 3, the cosine x equal to the 3 sine x here, correct? Okay, now you divide by cosine both sides. So divided by square root of 3, so you will have a 3 instead of square root of 3. So 3 over square root of the 3 over 3 will be equal to the sine x over cosine x. So basically what you did, what you do is move the cosine over to this end and then move the 3 to this end, right? Okay, now what is the sine over cosine here? This is a tangent x here. So now the tangent x is equal to the square root of the 3 over 3. So that's why I have the tangent x equal to the square root of the 3 over 3. So by unit circle, you still remember the unit circles here. So what is the tangents here? The x is what? 30 degrees, right? So or it's pi over 6. But because they have the, the tangents period is pi here, right? So I know this can repeat. So I know it will be pi over 6 plus k pi here, right? So of course, where k is the integer, because the period of the tangent is pi. So I know when x is equal to this, I'm going to have a horizontal tangent line, right? Because this is a sine cosine. So whenever like the angle reach the pi over 6 plus k pi, I'm going to have a horizontal tangent line. So for this problems here, the key things we want to know, what means horizontal? That means slope equal to 0. And the tangent line, what is the tangent line mean? The slope of the tangent line, that means the derivatives, right? Okay, so now number 4 is here. So this is the one we did before. Also, it's similar. We just used the, we just, used like the trig functions to, to represent it. Okay, so we say a car, repeatedly speed up and slow down as it drive at x seconds. That's why they have this periodical function, x plus sine x. Okay, draw a graph when x equal to 3 pi. All right. So like this is a sine x, right? And the 3 pi, so the 1, 2, 3, 4, 5, 6. Okay, sine is go like from 0 to 3 pi. So sine Oops. Okay, so the sine is go like this. Okay. So sine is go like this, right? So here is 1, and here's a negative 1 here, right? So this is a sine function. Then the x here, right? So the x, so here, this is the, if you put here, this is a pi over 2 pi, 3 pi over 2, so 2 pi, and this is a 3 pi. And the function of x, that's just a lines, right? So that means this line is 0 is here, pi over 2 is here. So this one it will be a straight line here. Okay, so then when you add them together, so if you add it, so the graph going to go somewhere like this. So this is the pi, 2 pi, 3 pi. Okay, so this is pi, 2 pi, 3 pi, pi, 2 pi, 3 pi. Okay, so the line going to go somewhere like this. Right? So let's use the graph here. And now this is what we call the position functions. That is where is this car will be. And now the next thing here we say, what is the velocity? Okay, so remember the velocity is what? We have like 3 functions, right? We have a position. So velocity is the derivative of the position. So that means I'm taking the derivative of f prime x here. So what is the f prime x? X is x plus sine x, right? So x take derivative is 1. Sine x is what? Cosine x here. Okay, and now the velocity will be f prime 2. So you just say f plus cosine 2 here. Okay, so you put it into the, your calculator. So cosine 2 is approximately to the negative 0.416. And now this is 0.584 meter per second. Okay, that's how fast it go forward, right? 0.584 meter per second. Okay, and then the next one's here, the part C, that's pretty easy, right? So let's say, what is the velocity at the pi when the x equal to the 3.1415 second? So I know that f prime x is equal to the 1 plus cosine x. So you want to find the pi, so f prime pi, so it's just a pi, right? Plus, I'm sorry, this is 1. Okay, so this will be 1 plus cosine pi. I know the cosine function is something like this, right? So cosine, this is pi. So what is the cosine pi here? Cosine pi is -1, right? So that means what is this? Is 1 minus 1 is equal to 0. So this is the velocities here. So when the velocity is 0, what's that mean? That means this car, okay, so this car is not moving, right? So this car we say is motionless. For an instant at the x equal to pi second. That means at that moment my car stopped, it's motionless, right? That's what it means of the velocity. And I think that's it for this section, how to take the derivative of the trig function. So one thing here is this is the main trig function formulas, right? So you need to remember this 6 formulas for the trig functions. And like in here, those limit is extremely important also. like I said, right now we use it and you treat it as you treat it as take for granted, and I'm not going to prove it because I'm going to use this result to prove my derivative. That's what we derived in here. So we're not going to do the more proof by using the definition anymore. So basically we just say, okay, this is the formula, and you need to kind of remember these 6 trig formulas here. All right, that's it. That's fun, right? And now after we get the trig, and then the next things here, we're going to talk about another very, very important rules is what we call it the chain rule. That's probably is one of the very, very important rules in the calculus 1 here. Okay, that's it. Have a good day, and looking forward to talk to you in our next lectures here. Okay, bye.